Dear colleagues, it is a pleasure for me to present our scientific results, which are displayed in the paper Method and Tool of Detecting Software Architecture Patterns in the Process of Computer System Development. The main idea of the developed method is to automatically identify design patterns using artificial intelligence approach to software requirements and meta description of reused software component. The main value of the method is to increase efficiency of designed patterns detection in the process of computer system development and to avoid developer subjective solutions. In general, reuse-oriented approach of software and computer system development includes 6 stages. These are requirement specification, component analysis, component adaptation, system design, implementation and integration, and system validation. The first 3 stages are different from other approaches, and we will try to automate them. Reuse components can be used in the different ways, like integration platforms, design patterns, frameworks, and others. Before developing a method of automatical detection of software architectural patterns, we need to explain some backgrounds which were published before. Requirement specification is very convenient to present in the structure of software quality models, which are displayed on this slide. The structure and relation between those models you can see here. Each model is a hierarchical structure with characteristic, attributes, and metrics. The attributes in those models are important to implement a method of patterns detection. On the other hand, each reuse component has a meta description, and we can define its attributes in the form of model of internal quality using expert analysis. The conceptual diagram of the design pattern detection process is shown on the slide. Here, as an input data, are used 2 models: model of requirements and model of architectural pattern. The process of adaptation includes procedures of building quality in use model, external and internal quality models. After that, neural network constructs and learns. The output of neural network is the probability of the best architectural patterns which responds to the requirements. The formal description of proposed method to define architectural patterns showed on this slide. Formula 1 display a matrix of requirements attributes, and Formula 2 display attributes of reuse component. Formula 1 and Formula 2. Formula 3 and Formula 4 interpret mapping matrices which respond to the software requirements matrix and pattern matrix. The structure of proposed neural network displayed on the current slide. The first input layer includes neurons with requirements attribute values. The next layers from 2 to n+1 are hidden layers with sigmoid activation function. The output layer is n+2 layer, which generate probability distribution for each pattern. The optimization process of proposed neural network made with backpropagation technique, which help to minimize mistakes. To automate process of pattern detection, we have developed web-oriented tool. Main functionality, requirements, and user roles for this tool are shown on this slide, like a use case diagram. Structure of tools components and their relation displayed as UML diagram. Sequence diagram showed on this slide, and class diagram showed on the next slide. More detailed algorithm of developed tool described in the paper. C# programming code of the neural network construction showed on this slide. In the end, the paper proposed a method and a tool for detecting and optimally choosing software architecture design patterns depending on the requirements for the system. The tool for detection and optimally selecting design patterns of software architecture of computer system makes it possible to ensure the efficiency of management of the system development process and due to automation, it provides high productivity and accuracy of decision making regarding the use of reusable components. Thanks for attention.